Good afternoon, my name is Eric Medina. I'll be introducing the project 4 with the ultrasonic sensor and its interaction with the Arduino program. Today we will be seeing like how an art like a project sensor works and how we will implement it on a program itself with adding it with a breadboard. So let's see, for example, first the program flow diagram will show us how exactly this program will help us turn on the LED lights and interact it with the ultrasonic sensor, which is defined as basically a measurement tool that uses sound waves as its to find the distance between the transmitter and its receiver. So basically here we're seeing that the distance, if it's over equals 30 or over 30, is going to turn on green. If not, if it's less than 20, it's going to turn on the blue LED. And if it's less than 10, it's going to turn on the red LED. And if it's less than 5, it's going to turn on the buzz on. And then from there, it's just out of range. If any object or any actual obstacle is not in front of it, it's gonna be showing us in the program out of range. Basically right here, it also shows all the instructions, basically, which is gonna just show us using the tools in the program. Here's our schematic circuit breadboard, which is gonna show us how to build it exactly and how properly it's gonna see. Here's our coding program that we're gonna use in the next part. And if we go back, we're gonna use this as a reference. Now, to build this, we're gonna need a breadboard. Let's focus. A breadboard. We're gonna need the ultrasonic sensor. We're gonna need a bunch of jumper wires. We're gonna need 3 LEDs exactly. It's preferred to different colors. The buzzer here, and our power supply. From there, it's gonna be connected with our USB cable. Let's start just by adding our sonic sensor. As you see right here, here's our transmitter and receiver. Both are gonna work to use it as a sound sensor and find the distance between our obstacle. Let's just make sure that we use the short sides as a negative side. Just to make sure, identify the short side of each wire, and we're gonna put it on the negative side of the breadboard. As you see, this is exactly how it's supposed to look. Now that we added all the LEDs, the buzzer, and our sensor already, now we're just gonna add the jumper cables now, and we're gonna make sure they're on the correct place. And we're gonna add our power supply, which is gonna be connected directly with our breadboard as well. So now that we have connected all of our wires together, as you see in each connection, we're gonna make sure that these wires are gonna connect correctly to each one of the or power supply. So to start, we're gonna make sure this ground supply is gonna be connected to this side right here. We're gonna connect our 5 volts into the 5 volts connected to our power supply. Inner ground on our power supply. Make sure these are on the correct spot, just as you see. From there, we're gonna use our echo and or transistor. They're going to connect both on the 11 and 12. Make sure it's 11 and 12 because they're going to be connected directly from the program. And now we're able to add all of our LEDs and buzzer as well. From all connect or buzzer connected to 2. And our LEDs connected from 5 through 7. Or as you can see. Just like this. Now as you see, this is our final result. And now we're gonna add the USB cable that's gonna connect to our power supply. Hello. So after this is added, after a connection is added, we're gonna open our program that's given by your instructor, and we're gonna put input our Arduino program. This is basically showing us the speed of the distance and the speed of each sound that's gonna bounce off of our obstacle, and show us which output or input is supposed to be on, and what properties are we gonna use. This is all just copy and pasted, and we're gonna put our delay to 500, so it takes like a lot faster than usual. Make sure you verify it before you upload it. We upload it to our program. And now we're gonna see exactly what just happened. We're gonna use the box as the breadboard. We're gonna put it a little bit separate so it doesn't show. As you see, the farther I am from the breadboard, the farther it is. The first light doesn't turn on. If I go closer, the first distance is gonna show us from using our tools and opening it with our serial monitor. It's gonna show us the centimeters of 16. Then if we go closer, 14. And then just from then on, the last LED should turn on, which is gonna give us the distance of 8 centimeters. And if we go closer, less than 4 centimeters given by the program, the buzzer is gonna turn on. Now, if we remove this, all the lights should like not work specifically, or like just turn off. As you can see, this is our receiver, and when you put it in front, as you see, if I put it in front, an object in front of it, it's gonna identify it, and it's gonna bounce up the ultrasound sensors back to its transmitter, and they're gonna combine it, changing it to energy and passing it through each one of the LEDs to the buzzer. In this case, we could use it as a way to find the when backing up in a car, you go find how far or how close you are to an object. If we see closely, we're gonna make sure that all the wires are correctly inputted, 13, 12, and 11. And then from here, the LEDs 7, 6, 5, 4, 3, and 2, which is from 5 to 7, and then just the buzzer on 2. And then connected directly from our sound sensor is going to be the 5 volts in the ground. From there, we use it as our advantage. Exactly just like that. We get closer, we turn on the second LED, which is less than 20. If we're over 20, it's gonna turn on the first LED. If we're less than 20, we're gonna turn on the second LED. Now we're less than 10, which is 8 centimeters. It's gonna turn on the third LED. And then as shown on the last result for the program, it's gonna show us the less than 5 is gonna turn on the LED, the buzzer, I mean. Well, thank you very much. And I hope this was a great lesson how ultrasonic sensor works and how it could be interacted with the actual real world. We could see again if you like for just we could see the serial plotter, and it's just gonna show us the base identity and how it's gonna decrease each time we get close to the program, to the actual sensor. Each time it goes down right here, it's gonna show us that each LED is going down with the distance, and it just goes back to its certain position. And hope that worked.